Okay, great. So, hello everybody, good evening, and thank you for joining the first episode of Learn with AngelHack today. We have Avinash, who works at Deloitte as a DevOps engineer, and he is also an open source contributor to cloud native projects and is also an AngelHack ambassador. Over to you, Avinash. Take us through how to get started with Go.
Sure. Thank you. Thank you, Harish. Hello, everyone. I'm Avinash, as you already know. So today I'm going to be walking you all through how to get started with Go. And a little bit about me before we get started. Harish already mentioned a lot of this, but yeah, I work as a DevOps engineer at Deloitte. I'm also an AngelHack ambassador, and I regularly contribute to open source cloud native projects like Kubernetes, Argo CD, and a lot more. So you can find me on Twitter at Avinash_UKR, and also on my GitHub at Avinash Upadhyaya 99. If in case you want to follow along my open source journey, please feel free to. And yeah, let's get started. So this is the agenda that I want to cover for today. So we'll start with why learn Go, and then set up an environment. I show you how you can set up an environment for using Go, and we'll go through a hello world program, and then go through the Go command line. That is how you can use the Go command line, and some variables and constants in Go, data types in Go, and pointers and user inputs in Go. So pointers is a very important concept in Go. So I'm going to go. I'm going to just touch upon that topic, but not nothing in depth. So just to get you started with it, and conditionals and loops in Go, just like with any other programming language, we'll cover conditionals and loops, and also we'll towards the end we'll also build a simple HTTP server, so you can see how it can be used in a real life example. And also towards the end, I'll provide some resources so that you can continue your learning journey. Some resources that I've collected and found beneficial. Yep. All right, so let's start with why learn Go, right? So there are a lot of programming languages. So why choose Go, right? So there has to be each use case. Each language has its own use case, right? So Go compiles to a single binary. So that is a huge use case in cloud native projects. So all of it, all of the code that you write compiles to a single binary, all the dependencies and everything. So you don't have to install anything to get these programs that you run running it on any machine. And it's also platform independent. Like I mentioned, it can be run anywhere. Once you compile it to a single binary, you can run it practically anywhere that supports it. That is almost everywhere. And also it has a very fast compilation and execution time. So that is why it is preferred in a lot of cloud native development, because it works with the inner uh, mechanisms like kernel, all of that. So you'll need it to be fast execution time, right? So it's also used in cloud native development, like I mentioned, and it's also a type language. So unlike a lot of other languages like say Python or JavaScript, so it is a type language. So once you assign a type to it, there's no you will not be changing it. So that is very beneficial. You'll see how it is towards it. And now let's get started with the hands-on. I don't have any other slides prepared. So let's start with the hands-on as to how you can get started. So the first thing on the agenda was to set up an environment for Go. So setting up an environment for Go, you'll need to download the Go binary, and then just like with the installation of any software, you'd click next, and install. So I'm not going to walk you through that. I already have Go installed. Uh, it is pretty straightforward to install Go. So I'm not going to cover that part, but I'll cover how you can set up an environment for Go. So when you install Go, you will have a few Go environment variables set up. So I'll show you those environments. So there are a lot of environment variables that are set up. So if you're not familiar with the environment variables, these are very global variables that have a particular value, and you can be used anywhere across your system. So I'm using a Linux-based terminal or a Linux-based machine. It is WSL. So if you're using Windows, there's a different way to look at environments. But even if you type Go env, you should be able to find the all the environments. But setting up environments in Windows is different from setting up environment variables in Linux. So I'm going to cover Linux mostly. And so there are a few environment variables. So if you find, we're looking for Go root and Go path. These are the two important variables that we need. So Go path is where you would store all the source code of your Go programs. So in my case, it is under home Avinash Upadhyaya and Go, and Go root is where the Go is installed. So once you have this Go setup, by default it is under your home directory, no matter the operating system that you're using. So if you don't already have that Go directory under your home directory, create one. So in my case, I'm in my home directory. So I'm already in my home directory, and I already have a Go directory created. If not, you can just use mkdir and create the Go directory. So once you create that Go directory, you'll change directory into that Go directory. Here you'll need three important directories. So those are bin, package, and src. So the bin contains all the binary binary files from your Go programs. So once you compile your Go, you'll, like I mentioned, it will create a single binary, right? So all of those end up in the bin directory. So if I go into bin directory and show you some of the binaries that have been created. So these are some of the binaries that have been created while I've been working on different projects. And now the package pkg directory, that is the package directory, contains all the packages that you install while working with Go. So here I go under mod. So these are some of the different packages that I've installed while working with Go in this machine. So whatever package that you install using Go get or Go install, I'll cover those commands later. But whatever package that you install will end up over here. And the important directory that we're going to be working with is the src directory. So, okay. So this is the directory where all the source code of your Go files would live in. So this is the standard structure that is preferred by all Go developers. So this is the structure that is followed. You'll need the bin package and the src directories. So once you create that main Go directory, you create these three directories, and you'll be primarily working with the src directory. So even under src directories, there is a particular hierarchy that you would follow. So it would follow the hierarchy of the package name that you would use. So for example, all package, usually the package names in Go start with github.com, and then the username and then the package name. So that is how you would name the directories here as well. So if you get it here, you'll find there is github.com, and there is another one that followed a different convention, but it's usually github.com and then the username. So here there are a few other projects that I've been working on. So each project's username, you create a directory and then clone the repository that you're working on in that directory. So in my case, I'll clone it, get into my personal username. And here you would create whatever project you want to create. So in our case, the first example that we're going to look at is an hello world example. So I'm going to create a hello world directory. So I've created an hello world directory. I'll get into that directory and open this up in Visual Studio Code. Okay. Okay, just give it a second. Okay, yeah, it is loaded. And the first thing that you'll need to do if you're working on a real project is initialize the project, right? So if you're familiar with other languages like JavaScript, so I'm going to constantly try to make references to other languages so you can map it here. So if you're familiar with say JavaScript, you would do npm init, right? So the same thing would be go mod init. So it would create a new go.mod. This is similar to package.json. Let's open it up. So it mentions the module. So this is what I was referring to earlier. So it is github.com/my username and then the project name. It also mentions the Go version that we're currently working on. So if I show you, oops. Yeah, earlier in Go root, you'll see my Go version is Go 1.7. You can also find your Go version using Go version command, and it'll show you your Go version. It's 1.17. So that is the Go version defined in the Go module. But for the programs that we are going to be executing right now, we'll not really need go.mod because we're not really using any external dependencies. We are keeping the examples as simple as possible. So you can initialize it or not. For these examples, it's not necessary. And the file that you're going to create or need is going to be main.go, or that is the main file where the execution starts, or it can be named anything. You just need to specify that file while you're running it. I prefer using it as main.go. And yeah, let's do this. So the first thing that you'll need while creating a Go file is creating a package. So if you're familiar with Java, there is a concept of package there as well. So all package usually compiles all related code in a single structure. So all related files for a single code come under a single package. So we're going to create a package main. And the thing about Visual Studio Code is the errors are really helpful. So whatever issues you run into, it resolves them pretty quickly. So it shows you the error pretty quickly. And once you define the package, you'll need a main function. Once again, like with Java, you'll need a main function. That is where the execution of the program begins. So if you're familiar with Python or JavaScript, there you'd not really need a function, right? You can just write code and then it directly execute it. But with Go, you'll need a main function. It has to be named main. So defining functions, you'll use the word func, a keyword, and then the main, open parenthesis, and then the cloud brackets. This is how you would define a function in main in Go. I'll zoom in a little, so I'm not sure if it is visible. Okay, yeah, this should be good enough. Okay, yeah. So once we've defined the main function, let's print something. Right, hello world will print hello world. So the function for printing hello world, or function for printing in general, is fmt.println. But if you notice, there is a red error over here that Visual Studio Code throws. So the FMT package, okay, Visual Studio actually automatically imported it, but we'll need to import the FMT package. It is not a default package that like you can directly use. You need to import it. So once you've imported a function, you can print any string over here. So here we're going to print hello world, and this is it. So you can import multiple such packages. So in case you are importing something from an external source, say from GitHub, so you'd provide github.com as a name and then the package name. And if you're providing multiple such packages, you'd provide each one in a new line. So here, let me import just math. Right. Okay, press saved. Okay. Yeah. So the thing about Go is it tries to keep the code as small, clean, or as small as possible. So in case you're not using a package, it will throw an error that you're not using a package, not a warning, an error. So you will not be able to run it if you have an unused package or an unused variable. So once I click save on in Visual Studio Code, it automatically removes it. But if you're using other IDEs, I'm not sure if there is such plugins which does that. But whatever you've declared or imported has to be used. Even the same goes with variables. Right. So now let's run this. I'll run it with a terminal over here instead of switching to my other terminal. Okay, we are in, and we'll run using go run and then the file name. Right, main.go. We get the output hello world. So it's as simple as this. Probably. Yeah. So this is how hello world program would look like. And yeah, let's go over the Go command line, right? I'll go switch over to the other terminal so that it's easy. Okay, I forgot to zoom into this earlier. Okay. Oops. Okay. So let's look at the Go command line, right? So go, and if I just type go, it'll show me the help command for Go. So that it'll show me what can be done with Go. So we'll focus on just these commands, not the additional commands. So to get started, we'll just focus on this. Go bug to start a bug report. That is not something we're going to be doing as a beginner. Go build. This is where you would build your source code into a single binary, right? It all compiles to a single binary, right? So you'd use this command to build your source code into a single binary. Let's actually do that with our current example. So we'll do go build and then main.go. right? So now we have a main executable. So now since I'm in Linux, I can just run this executable, and it returns me hello world. So if you're doing this in Windows machine, you'd get a .exe file. So you can just double click on that, and then it'll return you the same output. It'll just open a terminal and then return you the same output. Right. So it all compiles to a single binary. So you do that using the Go build, and then the Go clean is to remove some cached files. Let's not go through that. And the Go doc is used to get the documentation for a particular package. So if you're using some external package and you want to get the documentation for that, you can use the go doc command, and then they followed by the package name. So go in we used this earlier to get all the Go environment variable information, and go fix in case there is a package that is broken and you need to fix it. You'd use go fix. It'll make more sense once we get into a system where we use external packages. Um, Go format once again reformats the package source, very similar to what Go fix would do. And Go generate is not something we're going to use. Go get. So Go get is where you would install external dependencies, right? Go get and then the dependency name. So github.com username and then the actual package name. And Go install is also very similar to Go get, but what Go get does is it first downloads, then compiles and then installs. What Go install does is just compiles and installs. So the use case for using Go get or the difference between Go get and Go install is you can use a -d flag with Go get, and that would just download it without installing it. And then in case you want to make some changes on whatever is downloaded, you can make those changes and then do Go install. So that case, you'll have your local changes with that package. And then Go list will list all the packages that you already have installed. Go mod is for module maintenance, and Go run is the one that we used earlier to run our program. So Go run followed by the program name or the file name, and then Go test. In case you have test defined with Go, you can use Go test. You can configure the Go test to run those test cases, and then Go tool is to run specified Go tool. This is not something we're going to be using. And Go version, we used this earlier again. So this will print out your current Go version. And Go wet is report some mistakes in the packages. Again, something not we're going to be that again something that we are not going to be using right now. And yeah, these are a little advanced comments, something that not something we're not going to be using. So I'm not going to cover those. So let's get into the next part of the agenda, right? So the next part is we're going to look at variables and constants. So you can define a variable in Go using just var and the variable name equal to and then the value that you want. So this is also the right syntax, but I notice there's an error right now. So I mentioned that it is declared but not used. So let's use it somewhere. Let's just print it out and then just print the value. So now the error goes away. I'll remove this. Okay, let's run this. Go run main.go. We get the value 10. Just a second. Okay, yeah, we get the value 10. So here's how you can define a variable. So I mentioned Go is a type language, right? So we're nowhere mentioning a type for this. So Go automatically assumes the type for a variable that is defined. So in case you want to explicitly mention a type, you can do that right next to the name. It can be int 32 or int 64. There are a lot of different types. So if you run the output will still be the same. You can get the type of the variable as well. You can just use type of a. Okay, it seems the problem. Okay, just a second. I'll just confirm the command. Okay. Anyways, so you can also there's another shorthand where you can define variables. So suppose let's take a different variable. So you want to define b, and without using var, you can just use a shorthand and then define the value. So I'll assign this to a string. So just give the value a string. So this is also another way where you can define a variable. So here you would not use the var keyword. It will automatically assume it is a new variable and also assign the type. and you can define it using this shorthand notation. Just a second. All right. This was type. Yes. So yeah, you can get the type of a variable using the percentage %t, and then printf is very similar to println. So what println does is it prints everything in a new line. Printf formats whatever is printed. So we're using this escape sequence or escape sequence /n, and then this with percentage %t, and now we can place b. It will print out the type of b. So b is now okay. I've mentioned this as same thing, so might be a little confusing. B, right? So even if we now run it once again, it's return string. So it is returning the type of string. So if we do the same thing with a, it will return int64. Okay, comment this out. So comment is 2 forward slashes, just like with a lot of other languages. So now it is int64. If there's no type defined, it would be int, right? So it automatically assumes a type. So that is about the variables. Constants are where you would you have a particular value that would not change throughout the execution of a program. So that's where you would use constants. So you can define a const just like you would define a variable. So I'll define const pi. So we know that the value of pi will not change. So we can define that as a const, and then once again use that in our program somewhere, and the same result. So you can check the type. Even for constant, it assigns a type. So in this case, it will be float. Well, okay, is declared but not used. Okay, let me clear. See, it throws an error, not a warning. So it tries to keep the code as minimal as possible. So it is float 64. Even for constant, it assigns a type. Right. So this is about variables and constants. So the next thing that we want to cover is let's start with the conditionals, right? So conditionals is where you want to check a particular condition and then execute a set of statements based on that. So with a lot of other languages, there are if, and then else, right? So it is very similar in Go as well. So let's first define a variable. A is 10. And now let's have a conditional statement. If a is greater than 10, and then we'll print, okay, not if printf, we'll print a is greater than 10, right? So the next there's another branch that you can create, that is else if a is equal to 10. Now it will print a is equal to 10. Right, and else if neither of those two conditions match, it will print a is less than 10, right? So that is the more obvious one. And now let's execute this. So it match this statement, that is a is equal to 10, and it prints a is equal to 10. So it match two things using the equal to operator, that is 2 equal to. If you're assigning something, you usually use 1 equal to, and these are some of the relational operators, that is you compare greater than, or there's less than, and equal to, not equal to, right? These are kind of very similar to other programming languages. And yeah, this is about conditionals. There's also a switch state. So switch, and then you would provide the variable. And now case, in case it is 1, you do something, print if print a is 1. So while printing, you can also concatenate strings using a comma. A is 1. And let's have another case. where A is 10 and A is 10. And you can also have a default case. That is, if neither of these two matches, then this one will be executed. Just copy paste this. A is not 10, maybe. Yeah. Okay. Now let's execute this. Okay, 10 is 10. That is A is 10, right? This one was a match. So this statement was executed. So this is how our switch case work functions, just like with a lot of other languages. But yeah, this is how switch case functions. All right, so let's clear this. And let's look at loops. Loops, right? If you're familiar with other languages, I'll try constantly repeating this, but there is a concept of while loop, right? So where you would have one condition and then the loop executes until that condition is not satisfied. So in Go, there is no explicit while, but using for, you can do while. That is, you can do a while loop. So first, let's declare a variable 5, and then for A is less than 10, or wait, yeah, A is less than 10. We'd execute this loop, and we'll just print out and we'll increment A. This increment operator is where it would increment the value of A by 1. So each time this loop runs, it will increment the value of A by 1, and this is the condition it checks for. As long as this condition is satisfied, everything under this in this block will be executed. So it will print the value of A as long as the value of A is less than 10. So the initial value of A is 5. So it will enter this loop, it will print it, and then increment it to 6, 7, 8, like it keeps going on. So let's run this. Okay, we did not save that. Okay, now let's run it again. So it prints 5, 6, 7, 8, 9. As soon as it reaches 10, it is not satisfying this condition because A is equal to 10, not less than 10. So it no longer executes this block and then returns to the next statement, which is we have nothing. So this is how you can do a while loop in Go. And you can also do the traditional for loop with just like with the other languages. So you would have 3 paths for a for loop. That is, the first thing is you will initialize a value, and the next one would be a conditional statement, and then the last one would be something you would change the value with. So here let's initialize it to 5, and then A plus plus. Okay, A is already initialized. Okay, expected Boolean. Yep. Okay, yeah, we will use semicolon to differentiate between that. And now let's remove this final increment. Now this should also perform similarly to our previous example. Now let's run it. It returns the same output. Right? Okay. Yeah, it returns the same output, 5, 6, 7, 8, 9. Something wrong with it. Clear it. Okay, so we've looked at conditionals, loops, and now let's look at pointers. Right. So pointers are where special kind of variables where it would store an address, an address to another variable. So let's say you have a variable 5. So this has the value A that has the value 5. Now you want to store the address of this in a different variable. You can use pointers for that. We're using the ampersand and A. So now B has the value of the address of A. A has the value 5 and B has the address of A. So now if I print A and B, now I'll print them in separate lines. A and B. Oops. Okay, it's a little bigger. So A returned the first print statement, A returned the value 5, and the second print statement, B, returned the address of A. So you can also extract the value from a pointer, that is using this star asterisk. Now B would print the value in that particular address. So B contains the address, and now B would return the value in that particular address. So now let's run. Both of them should return 5. Yes. And you can also use the same pointer to change the value of that. So now let's change the value using the pointer to 10. And now I'll print yeah. Now I'll print the value of A once again, not B. So now the value of A would also be changed because we changed it using the pointer. So the pointer goes and changes the value in that particular address. So even though we did not change the value of A, we changed it through the pointer. So that is how pointers work. And what else can you do with pointers? I think this is it, just an introduction to pointers. So in case you have a variable and you're trying to change that in a different function, you'd pass it as a pointer so that it is updated in this function as well. So that is one of the use cases for pointer in Go. And the next thing would be taking user input. So now let's declare a variable A that has that is an integer, and we'll take we'll take user input first. Let's print out enter number. Oops, enter a number. And now you would take user input using the scanln function from the FMT library. So FMT is stands for format. If I did not mention that earlier, so it stands for format. So you can format a lot of things, that is printing and receiving input. All of that comes under the FMT library. So now let's take the user input. Here we would provide a pointer to that variable, not the variable directly, so that we want to change the value for that variable. So let's run this program. So it asks to enter a number. If I enter 5, okay, I should have probably printed it later. Let me add another print statement where it prints the value that we have just input. Let's print it and run. So it asks for a number. I'm going to give it 5, and then the very next thing it does is print that value. So here is also another use case for pointers. Right? So you would pass in the pointer for that variable, and then it goes in and then uses that address to change the value of that variable, and then we're printing it once again. So this is about user input and pointers. All right, so the next thing that we can do is I'll quickly just check the agenda to see if we're not missing anything. So we missed data types, interesting, right? So let's look at some of the data types in Go. So the two data types that I already introduced were, three data types that I already introduced were int, float, and string, right? So we've seen how you can define an int as some value, and similarly float 64, sorry, and a string. So this is how we would declare int, float, and a string. There are other complex data types like arrays. So arrays are series of such individual values. So array contains all of the values in an array would be of the same data type. So these are some of the primitive data types, that is int, float, and string. These are simple data types. So you can have multiple such values assigned to a single variable using an array. So let's define an array A, and then the type of the variable. And then this is how we would declare an array. And you can use the index of that array to assign a value. So let's assign a value, say hello. So here the first step, we are declaring an array using a var keyword, and then in the next step we are using the index. So indexes start with 0, not with 1. So we're assigning the first value of the array to hello. Similarly, we can assign the next value, that is to hello world. And you can also specify size of the array. So you want to have an array of say size 5, you can specify 5 over there, and I'll print out the array. Right, so it prints out hello world, and there are few blanks because the size of the array is 5 and we've just defined 2. If I make this the last variable, so you'll notice that there are gaps in between. That is, these are the empty ones that we did not define. There's another way you can define an array. So and this size always has to be a constant. So you can either specify the constant over here, or create a new constant using the const keyword and then specify that value over here. So this always has to be a constant. So another way you can do is directly assign it while declaring. So we'll have okay, let's make this okay. Yep. Okay. Or let's get into slices, right? That will make more sense. So slices is where you do not know the size of the array. So that is where you would use slices. So whenever you're using array, you would specify the size of the array, right, while declaring it. So when you're using a slice, you don't need to specify the size of the array. So you can just go variable name and then string, and then directly give the values of the array. Hello world. We'll also still need to mention it is an array. Wait, not over here. Wait, something seems to be wrong. Right. Oh, yep, my bad. So I forgot to assign it using the shorthand. So now this is how you would declare a slice. So this is very similar to an array, but here you don't specify the size of the array. So this can be any length. So now if I print the slice, it will just print hello world. And now I can keep adding on to this particular slice. So I can add the third element as angel. Right, it is still appended to the array. Right. Okay, so once you've defined a slice, you cannot extend the size of the slice. So, but you can directly use it while declaring it, right? So this is how slices and arrays work. The next thing is we'll be looking at loop maps. Sorry, and so you can define maps in two ways. The first way is you directly you'd use the map make keyword to define a map. So make, and then you define a map, and then sorry, yeah, and then the type of the key, and then value. So the key value is where you would have a key that contains a particular value. So it is like, I'll demonstrate an example. So here, say name is my name is Avinash. So this is a key value pair, right? So this is the key and this is the value. So this is how you would define a key value pair in Go, right? So this is how you define and declare an map, and then now you can assign values to these maps using the square bracket, and then the key. Since the key is a string, we'll have the key name equal to and then once again a value. So now in this map, the key name has the value of Avinash. So now I can print out the entire map or a particular key. So I'll first print out the entire maps, and so it prints the entire map. So map and then the key value. I can also fetch the individual key and then get the value for that. So now if it should print out just my name. Yep. So this is how you can define a map, declare a map separately, and then define it. There's another way you can do it. So instead of using the make keyword, you can directly define a map. So you can directly, without using a keyword, you can directly specify the key value pairs here. So the name would be name and then my name, and then another property age. I don't know. Okay, let's just have one. So this is another way where you can define a map or define it while declaring it. So declaration is where you would specify the kind of variable, and then defining is where you would assign a value. So in this case, we are doing both of them together. The earlier one where we used to make keyword, there we were declaring it separately and then defining it. So now if I print out the key value of name, it would still return the same thing, right? So these are two ways where you can define a map. So map is very useful when you're working with say key value pairs like JSON, if you're familiar with it. So that is where you would use maps a lot. So this is one of the important concepts there. And what other type? Oh, we have the struct type. So in Go, there is no concept of classes and objects. So when you want to have different kinds of variables in a single structure or a single component, you would use the struct. You would use a struct. So struct, and then defining a struct, first you'll use type, and then name of the struct, and then struct. And now here you can have a list of the different component different parts that you want in your struct. So a person would have a name, right, of type string, and then age of type int. And this is very similar to class. That is where you would have a blueprint and then you would instantiate that using a object, right? This is very similar to that if you're familiar with object oriented programming. But since Go does not have the concept of classes and objects, this is how it is. This is how it is defined. You have a struct and some properties for a struct. Now we can use this struct. We can define a new struct using p. No, wait. Var p person, and then is equal to, we can now define the values. So now it will be name is 22. Okay. Yeah. My bad. The syntax is sometimes a little confusing. Okay. Right. Right. We'll once again use the shorthand. Not really familiar with the var style. So we'll use the shorthand. And here we can use the name as Avinash, and then the age, 22. And now we've defined we've instantiated that structure. Now we can define, we can use that person structure that we've used and extract values from that. First, let's print out the entire structure that we've just defined. So it prints out the values without mentioning what is what. So now we can extract the properties from that struct. So now let's say we want the name. So person.name, and we get just the name. So this is how a struct works. And similarly, if you want, you can have functions for these structs. So let's create a function where it would print out the name. Okay, name of the person. So get name, and then it takes in person p person. And now all this function does is print out the person's name, p dot name. And now we can call this function from our main function, right? You can replace this get name and then pass in the person structure that we just created. So now the output should be very similar. We get the same thing. And in case you want to modify particular values, that is, if you want to say modify the name, you would have to pass in the pointer to this structure. So let me do that example as well. So in that case, I'll do func, and here I would pass in p person and then change name, and now I can change the name. I can also take arguments for this. So let's take an argument of name that has the type string, and now p dot name, I'll change it to whatever value that we passed to this function, right? So here we're passing the pointer to the function, and here is the arguments for the function. So this is um, so you can use this person object now and call this function, so it becomes an attribute for that function. So person dot, see, now we can see change name, and now I change the name to say Bob, right? Okay, let's not try to call it inside that function. Okay, now we've changed the name of the function. Now let's first do get name of person, and then similarly the same thing once we've changed the name, right? Now so earlier it used to be Avinash, now it is Bob. So this is how you can have functions for that particular struct. You just need to pass a pointer to that struct and then create a function using that. So you can whatever changes you make to this structure property is persisted wherever you use it next. All right, so this is about we covered struct, we've covered maps, we covered arrays and slices, and there is a concept called interface as well. So that is very similar to struct, and there's also a concept called closure, but I think I'll cover that in a more advanced session, since that would since that is not really getting started with code. So I'll cover that in a future session. I don't want to put too much information and confuse you all, right? I already was confused a couple of times during the session, so it is a bit tricky if you're new, right? So the next thing I mentioned in the agenda was to create a HTTP server. So this is a very simple server. So let's use the same thing. Let me clear all of this. I'll use the same file. Okay, the first thing that we'll need is we'll need to import the net HTTP package. So I mentioned earlier, if you have multiple packages, you would put them in new lines. So I'll import the net HTTP package. And now we're not using either of those. That's why there are warnings. And the first thing we'll need is we'll need to define some handler functions for it. Before assigning a handler function, I'll define a handler function. Handler function is where it would handle whatever root, when you suppose you hit a root slash or slash about. So you'll need a handler function that would handle the request coming into that. So here we'll create an index function. So this will take in a writer, http dot res, wait a minute, writer, write response writer. And the next thing we'll need is a request. We'll also take in the request, which will be a pointer to the request, http dot request. Wait, just confirm this. It's been a while. Yep, it is HTTP request, and this has to be response writer. Right. So we have the handler that we've created. So this handler handles whatever functions that are coming into this. We do not require this library. Yeah. So this handler handles all the requests coming into a particular route. Now let's connect this handler to our HTTP server. We haven't even created the HTTP server yet, but we'll first connect it. So we'll use the handle method, handle func method, and whatever comes into the slash route, we will route it to the index function, right? So in this function, what we can do is we'll just print out a simple thing. We'll just write fmt dot fprintf and just say hello. Wait, am I doing this right? Wait, we'll write a dot fprintf. Okay, we'll just not use the writer, and we'll just directly printer, and we'll pass in the response writer as an object. Right. So we've defined the handler for the index route. So whatever function, whatever request that comes into the slash route, that is the default index route, it will go into this function, and then it will just print out simple hello, or we'll make this hello world using this response writer. And the format function will just pass in the response writer as the destination for where it has to print. And next is the message that we want to print. So now we've handled the function, but we haven't created the server yet. So we'll create a server, http dot serve and listen and serve. Sorry, yeah, listen and serve. You can also have listen and serve TLS, where you would provide HTTPS, but this is a simple HTTP server, so we'll not be using listen and serve TLS. Okay, and the first argument for this would be the port number. Let's listen on port 3000, and then the next thing would be the handler. But since we're using the default handler, that is, we're directly using http.handle func, we're using the default sermux. So we'll keep this as null. Right. In most cases, this will be null if you're using HTTP listen and serve. It is only when you want to have a custom servmux, you will use a different value for it. By default, it will be for most cases it will be a nil. And now we have our server we have our server listening and serving at port 3000, and we have an index route that is handled by the index function. So let's run this. And go. So we have it running. Since we don't have a message saying that it is running, we cannot identify, but we have the server running on port 3000. Let's open, or let me go back to this, and I'll just make a call to that HTTP server. So I'm just using curl to call that. So I'm calling the slash route. So it returns hello world. Right? If I call anything else, it will not. It will still return the hello world because it is matching the slash. But we can have other routes. Say about. I'll just quickly make a change. Okay, I believe we're close to time, so I believe we'll get it right. So we can have multiple routes for this, right? Right. So now let's quickly cover some of the resources that I wanted to share. So these are some of the resources that I believe should be helpful. So for the first thing is exercism.org. It has a lot of hands-on experience for you to learn any language, not just Go. So it has a lot of examples where you can learn Go. So I'll share all of these in the chat once I stop sharing it. So this is a very good website for you to learn any programming language. And gopher.kubedaily.com. It is once again a similar hands-on it is hands-on, where you can learn Go. And Go by example has a lot of examples that you can use to learn Go. So example-based learning, that is very useful. And this particular tweet has a lot of resources that are shared in that as a reply. So I'll share this as well with you. And a lot of my presentation was based off this Michael Cate's 90 Days of DevOps, where they've covered Go as one of their topics. So in that, they've explained a lot of concepts in detail. So if you want, there are about 8 such markdown files where you can go through and learn a lot more about Go. And so you can also get started with contributing to Go projects. So once you've understood how the basics work, you can directly jump in and start contributing to some of the Go projects. So there are a lot of good first issues. If you go to this website, there are a lot of good first issues. And contributing with Go, say the cloud native projects, there are a lot of Cobra based CLI projects. So it follows a very similar structure. So if you've used any cloud native CLI, it has a very similar structure. Once you look at it, you will probably make better sense out of it. So it uses the Cobra library. A lot of projects use the Cobra library as the CLI tool. So it has a very standard structure which helps even beginners to get started with it. So once you have a lot of hands-on experience, you'll have a better grasp of the language. So I'd suggest you start looking at some good first issues and start working on it. Most of it use Cobra as the library, so it is easy to get started with, in my opinion, right? So these are some of the resources that I wanted to share. I'll drop this in the chat right now once I stop sharing. And yeah, question Q&A. So if you have any questions, I'll look at the chat right now and then we can get started. And thank you.
Wow, that was some insane level of marathon that you've run for the
Yeah, I
past.
try to jam out of
Yeah,
it.
brilliant,
That
brilliant, brilliant one, Avinash. I also learned quite a bit of what Go is. Let's quickly jump into the Q&A. Don't want to waste any time. I want to be
sure.
as fast as you are. I'll just ask what the questions are from the chat. And thank you so much for everybody who's stuck around for so long and haven't left really. So Gaurav is asking, is there any issue of indentation in Go?
So indentation, there's no issue as such, but if you're using the VS Code Go extension, I should probably mention that the thing that I'm using is an extension, does not come by default with VS Code. But if you search for Go in the plugins, you'll get that extension. And so it automatically formats the indentation. So based on the standard practices used by the community. So it automatically formats the indentation. So that is not an issue, I would say, but a best practice.
So another one, Harsh is asking, looks like Go is mostly like other programming languages. Why is it popular? And why is it used in most cloud native development projects? In fact, I also had the same question. What are some real world projects, right, where Go is being used?
Right.
If you
So
can share some
Kubernetes is
idea on
in
that.
Go, right? Right. Kubernetes is in Go, and a lot of other cloud native projects are in Go because once again, it compiles to a single binary. That is very important because if you're sharing these say files or programs across, you also want it to be as lightweight as possible. So with the Go thing with Go is, if you already noticed that it does not allow extra packages to be imported or extra variables to be defined. So all of that makes it really fast and lightweight to be used across cloud native projects.
Great. So how does one contribute to Golang in general? Where do they go if they want to start contributing?
Yes, so I suggested the website put first issues and then select the language, go over there. So you'll find a lot of CLI based Cobra SPF13 Cobra based projects. So that is very easy to learn. I mean, I could host a session on that in the future as well. That is a very interesting project. So you can use that, and a lot of projects use the similar structure. So once you get started with one project, you'll be able to jump on quickly to other projects as well. Once you learn that SPF13 Cobra.
So Hare Krishna Rai is asking, all cybersecurity tools are built on Golang. Why is it so? Any security features that it has?
So I'm not really familiar with any of the security features that Go would provide. So, but yeah, it is used a lot.
Cool. So I might have to ask you to pull your screen again.
Sure.
I have two personal questions. While I ask those, for the audience, do you want to follow up to this session where Avinash can go deep into probably one example of an app that he can build, or probably how you can start contributing to open source? If you want to follow up session, just reply in the chat with a wave, or just reply saying, yes, I want to follow up. And my question is, your terminal really looks cool. Are you using something like an Oh My Posh, or what is it that makes it look cool?
I'm
That is
using
one.
yep. Uh,
Go
all right.
ahead. Go
So
ahead.
yeah. So I'm using Starship.io. So if you go to Starship.io, there you can easily customize your um, you can easily customize your
The
terminal. So
terminal.
I'm using Starship. Yep. I'm using Starship.io. Okay, probably the link is not IO, but I'm using Starship.
Interesting. Cool. Thanks. And the second one is, what are some of the extensions if somebody is getting started with Go? Some of the extensions in VS Code that people can install, because a lot of your code was being auto corrected and a bunch of things were happening. What would you
Right.
recommend?
Right. So there's the default Go one that comes with Go, Visual Studio Code. So this is really helpful. I mean, this is really powerful. I think this is my maintained by Microsoft, so or by Google, sorry. So this is a really powerful and this does most of it. So if you have this extension, I think you're good to go. This is the only one that I'm using for Go. This is a really powerful one.
Great. I have one more question. Sorry for taking your time
Yeah.
off. We are
Oh,
2 minutes over time. My question is, when you initiated Go in the project, right? It created a GitHub link as the project reference, or I don't know what the term is. Does it
model.
also create a actual repo on GitHub?
No. It is just the module structure that is, since the file structure that I followed here is github.com, my username, and then hello world. So that is how it creates the module as well. So this has some of the standard hierarchy that is followed. So under SRC, whatever is the directory hierarchy, that is the module name for that. So under SRC, this was the directory that I created. So github.com / my username and then the hello world. So it does not really create a repository. So you'll need to create your using the standard git commands, git init, and then create it.
Great. So if you can quickly show up where people can reach you in case if they have any questions or if they
Sure.
want to get started with Go. You can reach Avinash at these handles that he's sharing on screen right now. He's also an ambassador. So if you are an AngelHack ambassador, you have full access to him on our ambassador Slack as well. Thank you so much, Avinash, for spending your weekend 1 hour with us. And thank you so much for all of you who have joined in today to learn Go. And yeah, we'll probably plan a follow up to this. There is some interest already coming in. We'll see what we can do after this one, and hopefully you'll also start trying Go and get started with Go. We'll probably do a basic DevOps session where we can teach you, because most of your students, teach you what DevOps is, because it's also something like ML AI overhyped, over talked about everywhere, but nobody talks really about what it is. So we'll also plan something like that. But yeah, thank you, Avinash, once again, and thank you so much, everybody, for joining
Thank
in.
you. Thank you for the opportunity, and thank you for everyone joining in. Thank you.
Awesome. We'll see you soon again with another Learn with AngelHack session, probably in a couple of weeks max. But we'll get you all the requests that you've shared. We'll get you JS, we'll get you Next.js based sessions, we'll get you Java, and we'll get you more on React also. So I've got a bunch of speakers lined up for all these sessions. All you have to do is just come, sign up, and join and listen into these sessions. Also, you can stream these later on YouTube on the AngelHack channel. With that, we'll see you in the next one. Have a great weekend. Bye.